Okay, welcome to Module 3.5 and our last video for Unit 3. Today we're going to look at patterns in the periodic table. So last video we looked at the structure of the periodic table and we talked about how there were patterns that occurred in it with certain properties. Well, we're going to look at those properties in detail today. So there is a number of different patterns and trends that you can actually see in the periodic table. So some of them are pretty basic, like how atomic number and mass number change as you move through, or what the groups and different families there are, or metals, non-metals, metalloids, and how metallic something is. But then we also see patterns with melting point and how reactive they are, and that changes across the periodic table. It depends on, are you on the right or the left, the top or the bottom? Are you in a column with metals or a column with non-metals, and all those sorts of things. So we're going to have a look at a bunch of those different properties and trends today. So atomic number and mass number are pretty straightforward. If you're going down a group, your atomic number is going to increase. Okay, remember your top left is is hydrogen, and that's going to have your lowest atomic number and lowest mass number. As you go left to right, top to bottom for both of them, it's going to increase. So moving left to right is also going to increase your atomic number. So as you're going across a period there, as you're moving down a group, your atomic mass is going to increase. Moving left to right, you will find your atomic mass generally increases. Now, as I've talked about in a couple of other videos, the mass number you have on the periodic table is a relative atomic mass, and this can be influenced by different isotopes to different amounts. So it is occasionally possible that you're going to find that the number may not always go up, but generally it does. There's only a couple of odd spots throughout where we do see it, drop back down and then go back up again, but they're very far and few between. Very few and far between. Get that the right way around. So there's not many of them. So generally speaking, we would say mass number always increases if you're going down or left to right across a group, across a period, sorry. All right, now we've talked about how some things in different groups behave in the same way. And so we actually have a bunch of different groups or families in the periodic table, and there's 5 there I want you to be familiar with, and their names. So group 1 is what we call alkali metals, and alkali metals are like your sodium and that, and when you put them in water, they're going to react really violently. Group 2 is alkaline earth metals, and these are kind of similar to alkali metals, but they have some slightly different properties. So they do tend to react violently with things, but just not quite in the same way that alkali metals do. Group 17, all the way across the other side of the periodic table now, is your halogens. So this is where fluorine and chlorine and bromine are, and these are some pretty nasty gases. When they're in the normal gaseous form and you breathe them in, they can be quite damaging. Don't freak out thinking about, but you said chlorine and there's chlorine in my pool. I'm talking about chlorine gas. It's when it's in that form, it's a problem. Obviously, you don't want to go drinking pool water with lots of chlorine in it, though, so I'm not recommending that either. Your final group there on the right, group 18, are the noble gases, and they're very different from the halogens. Because they have a full outer shell, their last shell is complete, it's got 2 or 8. 2 being only ever being helium, all the others have 8 in their outer shell. They're really stable. They're so stable, they actually don't react with other things. So we'd say they're inert, non-reactive. Now, if we go back sort of more to the middle, from groups 3 all the way through to 12, these are what you call transition metals. So it's a big chunk in the middle there. If you're looking, the first row of the transition metals starts with scandium, and it's the bit that goes scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Anything below those ones are transition metals. So those are our groups, and some of the key groups there. Now, we can also split elements into 3 categories. We can either talk about them being a metal, they could be a non-metal, or they could kind of be in between. And this is what we call metalloids. And metalloids are this group where sometimes they'll behave like a metal and sometimes they'll behave like a non-metal. They're on that boundary between the two. And you can see here that we've got a big thick black line going cutting through our snapshot of the periodic table here. And what that is that's showing where the metal, or it goes from metals to non-metals, and you'll find your metalloids either side of of the black line on the periodic table. Now, your periodic table may not have this. This is just trying to illustrate where it is on this periodic table. All right, so what makes a metal a metal? Well, looking at its properties, they tend to share very similar properties. So first of all, it's probably going to be solid at room temperature. Now, mercury is an exception to this. Gallium can get liquidy at very low temperatures, but we're talking more like 36, 37 degrees, not 25 degrees, which tend to be what we think of as being room temperature. Mercury, on the other hand, will be a liquid at room temperature. So for all the other metals, though, we'd expect them to be solid. They're also going to have luster, which sort of means they can shine up and be shiny and that sort of thing. They're going to be good conductors of heat as well as good conductors of electricity, and that has to do with how they bond and that sort of thing. They're also going to be malleable. Malleable means they're able to be molded and shaped into new things. And we know we can do this. We can heat them up really high, make them liquid, pour them into new things. But even before that, even if we're just heating them up, if you have a bit of iron and you stick them in a forge and you heat it up nice and hot, you can actually, hit it with a hammer on an anvil and you can reshape it into something else. They're also what we call ductile, and ductile is a very specific word. It means that you're able to take something, you're able to draw it out into nice thin wire, and that's something that we can do with metals. And they have high melting temperatures, which is why they're normally solid at room temperature, except for pesky mercury that likes to be a liquid at room temperature. So those are some pretty consistent properties that we see with metal elements. On the other hand, we have our non-metals, and they can be solid, liquid, or gas at room temperature. We see non-metals in all three states at room temperature. Some of the other properties we see with them is that they're not shiny, that they tend to be brittle, they're not able to bend. They don't bend, they just snap and break. They're brittle. They are poor conductors of heat and poor conductors of electricity. And they tend to have much lower melting temperatures, which is why many non-metals are actually gases at room temperature. All right, so those are some of the properties of non-metals. So you can see they're quite different to what metals are. Metalloids can share both those sets of properties. They might be, have a high melting temperature, but they're really brittle or something like that. So they'll share metal and non-metal properties. They're found between the metals and the non-metals in that periodic table. They're kind of a transition zone between the two. The sort of 8 we tend to talk about, that's boron, silicon, arsenic, germanium, antimony, polonium, astatine, and tellurium. So you can see there's some of them on the right there. They kind of look like metals, but they do have the ability to occasionally behave more like a non-metal. So a bunch of funny ones there. All right. Metallic character is just how metal-like something is. So we talked about the metallic properties that something can show. Metallic character is how strongly does it show those properties. And so as you move down a group, what we tend to see is that elements become more metallic. The closer they are to the bottom of the periodic table, the more metal-like they actually are. Doesn't matter where you are on the table. As you move from left to right, it actually goes the other way. They become less metallic because on the left, you're starting with your alkali metals. And as you go all the way to the right, you're getting into where the non-metals and your noble gases and all that sort of thing are. So going left to right, you actually become less metallic. All right, we've got a couple more to look at. The first one is melting point. It's just an example of one of the patterns we see with physical properties of elements in the periodic table. It's not the only pattern, it just happens to be the one we picked. Looking at groups 1 to 5. If you look at groups 1 to 5 and you move down that group, what you end up seeing is that the melting point actually decreases. On the other hand, if you're looking at groups 15 to 18, the melting point will actually increase. So on the left-hand side of the periodic table, the melting point will decrease as you go down the group. And if you're on the right-hand side of the periodic table, the melting point will increase as you go down the group. If you move from left to right, what you generally see is actually this pattern of melting point getting really high as you go towards the middle, and then it will actually start to come back down as you move towards the far side. So from left to right, it kind of increases, then decreases. Finally, the last pattern we're going to actually look at is reactivity. So if you're moving down a group and that group is made up of metals, then as you move down the group, the metal is going to become more reactive. So in a metal group, the ones at the bottom are more reactive than the ones at the top. On the other hand, if you're talking about non-metals, it's the opposite. If you're moving down a group that's made up of only non-metals, you're going to find that those elements become less reactive. So the ones at the bottom are less reactive than the ones at the top. The really reactive non-metals are the ones near the top of the periodic table. As you move from left to right across a period, we see a really weird pattern occurring because on the left, we have really high reactivity. And as you move to the right, what happens is that reactivity decreases. But then it will start to increase again until you get to about group 17. Group 17 is really reactive again. But as soon as you get to group 18, the last group, your noble gases, you're getting to a group that are inert and non-reactive. So it goes really high, it drops down, comes back up, and then it goes to completely nothing. So that's how reactivity changes as you go left to right across a period. So here's a bit of a summary of that. So as you can see, as you go down a group with atomic number and mass number, it increases. And as you go across a period, it also increases. Melting points, you can see how it moves for those. Reactivity, you've just got to remember that group 18 elements are inert. So as you're going across a period, it's high to low to high and then nothing with group 18. In terms of metallic character, if you're going down a group, generally it increases, and as you're going across a period, it decreases. So those are the patterns that we see in the periodic table, which is pretty cool. And so it's not all of them, like I was saying, it's just a sort of a snapshot of some of the key ones that we do see. Now, there's a lot to take in there, and it's really helpful to get your head around what you're actually talking about by getting your hands on a periodic table, and there should be one you can download and print off. And what you should be doing with that is labeling a bunch of different points on it. So you can see here a bunch of things for you to do. So across the top, label the groups 1 through to 18. So at the top of every column, you'd write a number. So you'd start with the one above hydrogen, you put 1, then moving across to where beryllium is, above that column, it'd have 2, all the way across, and the column with helium would have 18 on it, above it. And on the side, for the rows, you'd label the rows 1 down to 7. Then, identify the groups, like where are the alkali metals, where are the alkali earth metals, your transition metals, your halogens, your noble gases, label those so you can actually see on the periodic table where those groups I was talking about actually are. Then color it in. Use one color for metals, one for non-metals, one for metalloids, and label it so you can know what you're talking about. Finally, with those different patterns we talked about, draw some arrows, one vertical and one horizontal, and then on it label and describe what happens with each type of pattern. Is it increasing, decreasing? Is it doing something funky? Does it change at this point because it's groups 1 to 5, or is it groups 15 to 18, or is it a non-metal or a metal? How do things change with that? So that's something that's really handy for you to do. It's an activity that you can do to help you with your revisions. You can go off and do this after the video. Anyway, this is actually the end of the video. So thanks for watching this video, and hopefully all the others as well. Remember, if there's anything you didn't understand or you need to go back over it, you can rewind, you can jump back and forward, speed it up, slow it down, do whatever you need to do. If you still have questions, go and ask your teacher. They're more than happy to help you. But that is it for not only this video, but also for the end of Unit 3. So thank you for watching this, and we will see you in the next unit. Bye.
And now, ASAP Science presents the elements of the periodic table.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the sign, sodium for salty times,
magnesium,
aluminium, silicon,
phosphorus,
then sulfur, chlorine, and argon,
potassium,
and calcium so you'll grow strong,
scandium,
titanium, vanadium, and chromium, and manganese. This is the periodic table, noble gas is stable, halogens and alkali react aggressively. Each period will see new outer shells while electrons are added, moving to the right. Iron is the 26th, then cobalt, nickel coins you get, copper, zinc, and gallium, germanium, and arsenic, selenium, and bromine, film, while krypton helps light up your room, rubidium, and strontium, then yttrium, zirconium,
niobium,
molybdenum, technetium,
ruthenium,
rhodium, palladium,
silverware,
then cadmium and indium,
tin cans,
antimony, then tellurium, and iodine, and xenon, and then cesium, and barium is 56, and this is where the table splits, where lanthanides have just begun, lanthanum, cerium, and praseodymium. Neodymium's next to promethium, then 62, samarium, europium, gadolinium, and terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium, hafnium, tantalum, tungsten, then we're on to rhenium, osmium, and iridium, platinum, gold to make you rich till you grow old, mercury to tell you when it's really cold,
thallium,
and lead, bismuth for your tummy,
polonium,
astatine would not be yummy,
radon,
and Radium will last a little time.
Radium,
Then actinize at 89. This is the periodic table. Noble gas is stable. Halogens and alkali react aggressively. Each period will see new outer shells with electrons are to the right. Actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, isonium, fermium, and olevium, nobelium, lawrencium, rutherfordium, wm, sprigium, boreum, hesium, meitnerium, dubsidium, rhenium, copernicium,
nihonium, flerovium, moscovium, livermorium, tennessine, and organesson.
and then we